Okay, number 18. Actually, this problem came from your website. So like I would love to give you one example, which is application problem. But like, and I recommend try to solve like a couple more problem from your instructor, okay? So for this problem, like, look at that. So like, they would like talk about the daycare, the rectangular playground, okay? So I strongly recommend whenever you have this kind of problem, and please draw the rectangle, okay? That is your playground, okay? That's enough. When I taught this course, whenever you draw this rectangle, I gave 1 point, okay? Even your answer is wrong, okay? So, but, I don't know about your instructor though, but, whether, like, this one, let me give the dimension about this, okay? Let's say this is what X and this is Y. Okay, and therefore this is also Y and this is X. Okay, but look at the problem. The final question, like you have to check the question. Okay, it is very last line. Okay, they said find the length of the brick fence that will minimize the cost. Okay, so basically this problem will talk about the cost. Okay, so we have to set up the cost function, which is target function. Okay, so before starting this one, look at the first line. The area given by 9, 10. Okay, so they said the area is 9, 10 square feet, right? Which can be calculated by X times Y. We're gonna use this one like to update my target function. Okay, so my target function, which is cost function, is let's look at that. They said like 3 side cost 5 per foot, right? So let me decide 3 side like this way. Maybe this side, and this side. Let me use $5 material, and for this side, I'm gonna use the brick, which is $10. Okay, so my cost function will be consists like this way. The first one, $5 side. The length of $5 side is X plus 2Y. Okay, and then what about $10 side? It's just simply X. Okay, so like look at that. This cost function has 2 unknown variables, right? But the real title of this course is single variable calculus. So like we have to replace one of the variable with the other one. Okay, so for that purpose, we're gonna use the area information. Okay, since X times Y is 90, and I mean 910, then I can write your Y in terms of X. Okay, then I will plug in this one into my cost function. Then I can update my cost function as the single variable function. Okay, let me solve it. Okay, and my cost function will be the function of X, which is equal to 5 times X plus 2 times 9, 10 over X, and plus 10X. Okay, so just simplify. Okay, it is equal to 5X plus 10, 9,100 over X plus 10X. So my cost function is 15X plus 9,100 over X. That's it. Setup is done. Okay. So now we have to come back to the problem. Okay. Give me 1 second. Let me try to make it a little bit smaller size, because I'm not going to have enough space below this one. Okay. Okay, fine, better. So now let me come back to the problem. Look at the problem. The main question is like find the minimum of the cost. Okay, so now since we find the minimum, and I mean we set up the like cost function, now we have to just focus on finding minimum of C, okay? So do you remember the step to find the minimum of, like, function? So first step is we have to take the derivative. The purpose of this derivative is like to finding like critical number, because all the critical number will be the candidate for the local maximum, local minimum, okay? So let's start from there, okay? We need C prime, that is equal to 15. And also, like, 1 over x prime is negative 1 over x squared. It'll be minus 9,100 over x squared. To find critical value, we're going to set that equals 0. Okay. Then, okay, let me solve this guy, okay? So let me use the like common denominator. Then if I set like x squared as the common denominator, it can be like this one. Again, whenever your fraction equals 0, that means your numerator part is equal to 0, okay? There's no way to make your equation equal to 0 with denominator, okay? This is it. Then 15x squared equal to 9,100. Then your x squared is 9,100 over 15. Maybe we can simplify a little bit and divide by 5 top and bottom. 1, 8, 2, 0, and 3. I think that's enough, okay? Then finally, for x equal to plus and minus and square root of 1,820 over 3, okay? But like, keep that in mind. We are talking about the dimension of the rectangular like playground, okay? So, which means you don't have to worry about sign, because like we're gonna take the like positive value on, okay? So for my convenience, let me try to use the approximation value. Give me 1 second. It is approximately 24.6, okay? So what is next step? Whenever you find the critical value, then you have to verify the critical value will give you the maximum value or minimum value. For this problem, we hope like it will give you minimum value, right? And there's two ways. We can check sign chart, or we can use the second derivative test, right? So for this case, like second derivative test might be easy, or like it's up to you. You can do it either way, okay? So let me try to use second derivative, okay? Second derivative of the function is like 15 prime equals 0, and the second part, which is minus 9,100 over x squared, they can be written by minus 9,100 times x to the minus 2. Then take the derivative of that function, your negative 2 come out, which is positive now, and double, which is 18,200 over x cubed. Okay, then we're gonna plug in, we're gonna substitute my critical number. Then we're gonna check the sign of this guy. Okay, but as you can see here, definitely it is positive. What does it mean? The shape of like this graph will be concave upward at this point. So we can conclude like this way. C has a local minimum at x equal to 24.6, right? So what does that mean? Since there's no other critical value, and this local minimum will be the absolute minimum. Is that okay? So now, like, let me check the problem, okay? Oh, the question asks you to find the length of the brick side, right? Which is x, right? There we go. Then we found like, x already, which is brick side, okay? So the final is like to minimize the cost, the brick side must be 24.6 feet. That's it.